the most common iterator in Rust and basically any other language. It's going to be your for loop. The for loop is the most common iterator that you'll be using. Typically, you want to use a for loop because you want to iterate over a collection of items. Within any other language, you also have other kinds of loops, like a while loop, or just an infinite loop, an unbounded loop that you can escape from using the break statement. With a for loop, you typically want to use that when you already have a predefined a number of collection of items that you can already know what the quantity is. And this is a really good use for a for loop because you know that you're going to be iterating over a collection of items. And a nice little jump into that would be the for loop, which is kind of... This is the most common pattern. It's like, okay, look, line 3 here is really important because we're going to be seeing a lot of the same thing going on. It's just the pattern is just slightly different in any of these cases. So you've got a while loop, a regular infinite loop, and then you've got a for loop. You've got 3 kinds of loops, and they're all basically the same. They're all just it's just slightly different syntax. And this is like a nice toe in the water. Let's get started with a for loop. So this is the most critical line here, line 3. We're going to have an iterative element. The in will be our variable, which is going to use a range statement. And a range statement is going to allow you to create an iterable list. So 1 to 100 in this case, even though it says 101, it's really only going to go to 100. This is on purpose. Even though it's slightly confusing, it's on purpose because often the second element, so you've got the first element here and the second element, will be a length statement that defines how many elements are inside of like a collection of elements. And when you specify the length, it's always going to be the total number. However, when you iterate it, this is the numbers start at 0. So really it's like 0, but if you had an element, sort of like a collection that was 101 elements, you really only want to go to this number because inclusively 0 to 100 is 101 elements, because you're including 0. So the whole idea with the for loop is that it's meant to be used with an iterator. And an iterator can be added into your system, added into your components, your structures, using an iterator trait. You can implement the trait for an iterator to convert a list into an iteration. With the range operator, you can define 2 data points, starting and ending. So it starts with A, the first element, which is going to be inclusive of that element. So 1, right? In this case is what they have in their example. And then exclusive, which means it's going to only go to 100 instead of 101. Yeah, I know it's a little confusing. I would prefer it's less confusing in the matter, but it's on purpose. It's very intentional. So if we run this program, we'll see we get the first element, we go to the very end, 98, 99, 100. So we don't see 101. But if you do want it to be inclusive, you can make that happen just by putting an equal sign there. So this will give us the exact same thing. This is exactly the same as this here. Let's go, here we go, there. These 2, line 3 and 4, they're the same. They're exactly the same. They have the exact same outcome. It looks weird. The syntax looks weird, but at least they let you do it. That's nice that they have the option for it. I have to, here we go. All right, so we can press play on this and we should get the exact same thing. Yep, we start at 1 and then we end at 100. So 98, 99, 100. So that's the range operator. Really clean, simple, straightforward, kind of nice. This is where you will always want to use a for loop iterator, and this is the best place for it in Rust. And any other language, really. It's when you have a collection of elements that you know it predefined, it's already there, it's already in memory, and you want to iterate through that list. And Rust gives you some really good options using iterators. The idea with an iterator is a construct you can interact with the iterator in several ways. You can create an iterator trait by defining it like this, implement the iterator, and the trait looks like this. You've got an item, and then you've got the next. Oh, that's a really easy to implement trait. Nice. Implementing iterators is really straightforward. Okay, that's for a future thing. So if you wanted to make your own iterator, you could do this. It's actually really clean. I like that. The one thing I don't like is that it requires you to execute it. I feel like if you're going to be implementing a trait on an item, the language would know to automatically have a default iteration. If I play this, it's probably going to give me an error. Yeah, it doesn't know. It has no idea. You need to say .iter. That would be a nice upgrade for the language to be able to support an iteration. It would know, since it's a trait that's built into the language, it would know that that can happen. There are 3 types of iterators. We have the into onto iter, the iter, and the iter mute. They all basically do the same thing. They iterate through your collection. Why would you want to use one over the other? By default, I recommend always using just the regular iter, right? In this case, what it's going to do, it's going to borrow or essentially reference the data that's already there, and it's going to be the most performant, and it's going to be read-only. So it protects you because you know that you're not going to mutate that list. You just need to loop through it to capture data. This is the best use for iterations, and this is probably the most common for loop. You want to do this as much as possible in this pattern because it's efficient, and if you can keep it in this direction, you're going to create a really good performant application. And it's also safe because it's read-only. So they have this, match statement in here that you can use to like sort of filter out the data and then print out the information. You could just do something simple like this where you print out each element, right? Because you want to go through it. The example is giving you an idea of how to like sort of search through the data and find the component that you're looking for. Usually that's what's happening is what you want to do in Iterator. You're looking for very specific items in a collection and you want to capture that data for some reason. What's really powerful about this, since it's read-only and it doesn't mutate the data and it doesn't create a copy, it's gonna be really fast. At the same time, you can continue to use this list of this collection, right? You can continue to use it in future statements. So that's why this is a really versatile nice, because it's clean, easy to read. You don't have to do any extra work to create clones of the data or have any locks in the system. It's just going to be the best approach. Now, here's another one, into iter. What this is going to do is create a copy of the data. Or that's what I really wanted it to do, but it doesn't do that. It actually does kind of the opposite. It takes the current copy, the current list, and it makes it unusable in the future. So it actually, instead of making it usable and referenceable in the future, actually completely does the opposite. And it will take that data and consume it, and it's gone forever. So you're like, why would you ever want to do something like that? Well, here we go. So what happens is that instead of using iter, we say into iter, which will let you use the data however you want inside this loop. But once you've done that, it is no longer usable. So this line right here, line 11, nope, sorry, that array, that vector, that list of items here has already been consumed. You can no longer use it. This actually seems like it could be okay for some situations where you are for sure not going to be using this list for anything else later on. You want it to be consumed and you want to make sure that it's never used again in the future. I would say that's a kind of a rare situation, though in certain programming situations, this is what you want. You want to make sure that that list just does not get consumed again, ever, for any purpose. And this is how you do it. It's sort of like locking the data. So if we run this, we get an error because we attempt to use the data, even though we're reading it. So what we do is we just say, oh no, none of that, and then we print it. So the data is consumed, the into iterator will permanently just sort of lock the data away. Now let's say you really do want to make a copy of the data. All you have to do is type .cloned in front of it. Now you've made a copy, and then you're making sure that copy itself won't be consumed anywhere else. So that is something that you could do. And then this line should work. I'm pretty sure. Let's see. Let's make sure we don't get any errors. Okay, success. So that is another approach that you can use. And what's great about that is that none of the data is accessed or touched. It's just a copy is made, and then you're looping over that copy. This is more computationally expensive, more memory intensive. I don't see too many scenarios where you would even need to do something like that. All right, now we've got our final approach for iterators with the iter mute. You can iterate over your collection, and then you are giving yourself read and write access to the data through a borrow, which means that you'll be able to use that data going forward. This is going to be probably a very common use case. A lot of development requires you to sort of modify the data. You're going through a list, you want to do something to the list, and then you want to keep that data around afterward. This is a very common pattern that we see in many languages and many programming scenarios that most developers are probably familiar with this approach. So we need to make sure that our list is mutable by putting the mute, and then we iterate mutable, which means that we can go over the data, read it and mutate it, and then also use it in the future again. Why wouldn't you always want to use this approach? It's the most flexible. Well, under most conditions, you probably will. You probably want to use this approach. There are scenarios that you will want to make sure just to protect yourself. So you're building into you want to use as much of Rust's protections capabilities as possible. So if you know that you only really want to have read-only access to your list, you will just use the standard iterator. You don't need to mutate. So you don't need to give yourself write access. So there's no reason for you to add mutation to it. This is the syntax they use here is kind of a neat little syntax fun here. What they're doing is they're assigning a reference to the name. They're dereferencing. What's going on here? So we've got name, and name. So we've got the name, we're matching on the name, which is going to be the names of the elements here. And then we've got this dereference name here, which means that we're going to be updating, we're going to be assigning, because we've got a reference. This is a reference here, right? So it's an and string, but we want to be able to dereference it to assign it to the results of the match. We want to find Ferris, and it's going to be a referenced, a borrowed data that's mutable. And then we want to say, hey, there is a rustration among us. So the last element will be this, and the other two elements will be this. So we're actually modifying the data here, and at the end we get hello, there is a rustation among us. I wouldn't necessarily say this is the easiest example. I mean, you probably could just do something like this. Here's a really easy example. We're just overriding all of these variables, which is great, which means it's really easy for us to take the data here, dereference it because it's a reference, and then assign it data. This means that we can mutate the list in a simple for loop. That's kind of clean. This is where you'd want to use this star thingy. When you've got a reference item and you want to dereference it so you can assign it new data, that is a really good case for using this star symbol.